Hi all, welcome to Learn Easy channel. Today's topic is molecular orbital theory from class 11. In this video, we are going to see the postulates of molecular orbital theory and how to draw the molecular orbital structure for various molecules. Okay, first we'll see the postulates. The electrons in the atoms are present in various atomic orbitals. Same thing like electrons in molecules also will be present in various molecular orbitals. There are many similarities between the atomic orbitals and the molecular orbitals. Okay, the second one is the atomic orbitals of same energy combine together to form molecular orbitals. An electron in an atomic orbital is influenced by one nucleus, whereas in molecular orbital it is influenced by two or more nuclei. There are two types of molecular orbitals. The first one is bonding molecular orbital and the second one is anti-bonding molecular orbital. Bonding molecular orbital has less energy and stability compared to anti-bonding molecular orbital. The electrons getting filled in the molecular orbital is of the same manner as that of the atomic orbital. These are the postulates of molecular orbital theory. The molecular orbital sigma is formed by addition of atomic orbitals that we are saying as bonding molecular orbitals. The molecular orbital sigma star is formed by subtraction of atomic orbitals that we are calling as anti-bonding molecular orbitals. Here sigma is the bonding molecular orbital and sigma star is anti-bonding molecular orbital. So the order is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s and then pi 2px equal to pi 2py, then sigma 2pz, pi star 2px equal to pi star 2py, sigma star 2pz. You have to remember this order, children. Then only when they give whatever is a molecule, you can write the electronic configuration. Okay. Now electronic configuration of molecules with electrons greater than 14. Both are same. Only one thing is different. Here after pi you get sigma 2pz. But here it comes in front itself. Like sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. After that you have to write sigma 2pz. Then your pi 2px equal to pi 2py will come. This is the only difference between this one and this one. This you should remember. Then only you can write the electronic configuration and you can draw the molecular orbital structure also. Now we will see how to draw the molecular orbital diagram of hydrogen. Hydrogen has two electrons, so 2 into 1 is 2 electrons. Since H2 is a molecule, the electronic configuration will be sigma 1s2. So we have to fill the lowest energy level diagram, sigma 1s, 2 electrons here. Okay, then in atomic orbital we have only one electron. For one hydrogen atom we have one electron. So we have to fill one electron in 1s orbital. Okay, this is the lower energy level sigma 1s, and this is a bonding molecular orbital, and sigma star is the anti-bonding molecular orbital. It is a higher energy level. Usually the lower energy level will be more stable compared to the higher energy level. Okay, now we'll see for helium. Helium, the total number of electrons is 2 into 2 is 4 electrons. So electronic configuration will be sigma 1s2, sigma star 1s2. Okay, when you take the atomic orbital 1s2. Okay, now fill the molecular orbital sigma 1s2 in 2 electrons and then sigma star there is 2 electrons. When you take the atomic orbital for helium, it has 2 electrons. So when you draw 2 electrons here. This is the molecular orbital diagram for helium. Now we will see for lithium. The number of electrons is 6 here. So electronic configuration is sigma 1s2, sigma star 1s2 and sigma 2s2. So we have to fill 1, 2, 3, 4, 5 and 6 electrons. So 1s, sigma star 1s and sigma 2s. Okay, and the atomic orbital configuration is 1s2 2s1. So 1s2 2s1. Okay. Now we will see for boron. The number of electron here is 2 into 5 is 10 electron. So molecular orbital electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2 and pi 2px 1 electron and pi 2py 1 electron. You have to fill first 1 electron each in 2px and 2py. Okay. 2, 4, 6, 8, 9 and then 10. So total electron is 10. Atomic orbital configuration is 1s2, 2s2, 2p1. First we'll fill the atomic orbital configuration. Sigma in 1s 2 electrons, 2s 2 electrons and 2p 1 electron. Now we fill the molecular orbital configuration. Sigma 1s2 2 electrons, sigma star 2 electrons, then sigma 2s 2 electrons, sigma star 2s 2 electrons, then pi 2px 1 electron, pi 2py 1 electron. Okay. Now we will see for carbon, the total electron is 12. 6 into 2 is 12 electrons. So the electronic configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2 and pi 2px 2 electrons, pi 2py 2. So total comes to 12. Okay. Atomic orbital configuration is 1s2, 2s2, 2p2. First we fill the atomic orbital configuration. In 1s 2 electron, here also 2 electron. 2s 2 electron, 2p 2 electron. Okay, 2s 2 electron, 2p 2 electron. This is 2p. Okay. Now fill the molecular orbital configuration. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2 and in pi 2px 2py you have 2 electrons. So totally it should come to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 electrons are filled in the energy level diagram. Since carbon has a number of electrons less than 14, in the electronic configuration, the pi 2px 2py, this orbital will come first and then sigma 2pz orbital will come. If the electrons are greater than 14, for example, for oxygen, you will get 8 into 2, 16 electrons. For those type of molecules, this one sigma 2pz orbital and this pi 2px and 2py will swap itself. In that case, this sigma 2pz will comes first. Okay. Now we will see for oxygen, the total number of electron is 16. So the electronic configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Next we have to write sigma 2pz first because greater than 14 electrons, I said the electronic configuration will be like this. So sigma 2pz 2 electron, pi 2px, pi 2py 2 electrons and pi star 2px 1 electron and again pi star 2py 1 electron. So totally 2, 4, 6, 8, 10, 12, 14 and then 15 and then 16. Okay. Now we start filling the atomic orbital configuration. 1s2 2 electrons, 2s2 2 electrons, 2p4 4 electrons. Same here with 1s2 2 electron, 2s2 2 electron, 2p4. Okay, 4 electrons. Now we'll fill the molecular orbital configuration. Sigma 1s2 first. So 1, 2, 3, 4. Then fill sigma 2s, sigma star 2s. Then sigma 2pz and then pi 2px 2py, then pi star 2px 1 electron, pi star 2py 1 electron. I summarize once again. The electronic configuration of molecule with electrons less than 14 is, the order should be sigma 1s, sigma 1s star, sigma 2s, sigma star 2s, and then pi will come. Pi 2px equal to pi 2py, sigma 2pz, pi star 2px, pi star 2py, and then sigma star 2pz. In the case of electrons greater than 14, the sigma 2pz will come first. So, and then the pi orbital will come. This is the only change in the electronic configuration. Please remember this. I hope you understand this concept. If you have any doubt, please post your doubts in the comment section. Thank you and thanks for watching.